Hello again and welcome back to another series of WildDream tutorials. Today we're going to be discussing how you can use a string of LEDs to create a very cool LED chase effect. So in terms of kit, what do we have here? A breadboard with 10 LEDs, 10 jumper cables that go to pins 3 to 14, and then one of the cables going straight to the ground. Another small cheat that I've employed in previous lessons is I've connected all the ground pins of the LEDs, so those are the shorter pins, on the same row with the ground. Another thing we're going to employ during this tutorial is this, a potentiometer, which I'll proceed to connect here on the right side of the breadboard, where I've saved 2 wires and then another wire here for grounding it. Okay, let's start with the LED. Now, I just hit create new application, call it LED Chase, make sure it's a visual programming project, click next and submit, and then find its name and click it here in the interface. Okay, we don't need to print anything on the screen now, so what's the first thing we're going to do? I'm actually going to connect my board now so that it has time to load up. Okay, so make sure that you either follow our notation or update the notation that you have in your own applications. In our example, the LEDs are connected on pins numbers 3 to 14. So if you want to start from another pin, you're going to have to change the code. What the code is basically going to be is moving on from a current LED, we're going to be doing modifications to the system. So 10 LEDs must turn on and off, one after one, until the first one gets to the last one, and then it goes back again. So we're going to be using 2 variables here. One of them is the current LED, and the other one is the direction. So let's add them now. Under Program, set this current LED to pin number 13. This would be the pin on my left, and then I'm also going to set another variable called direction and make that 1. Basically, what we're going to be using this direction variable for is increasing and decreasing the number of the LED which is currently being modified. We also need to have a little bit of a delay here, so add a quick variable to 400. So those would be 400 milliseconds. We're going to be using that later. So set the delay to 400. I'm just going to add this variable now because we're going to be employing the use of the potentiometer in order to increase and decrease the speed at which the LEDs are changing. So you'll see, it'll be pretty cool. Moving on to the loop now. We're basically going to initialize our LEDs. So counting from 4 up to 13, one at a time, we're basically going to set the LEDs on and off. So go to Peripherals, under LED, set on pin I. We need to add this from the Variables tab here. Okay, so starting from 4 and going all the way to 13, all of the LEDs will first be turned off, and then I'll have a small delay. And then we'll turn all of the LEDs will be turned on, and then I'll have a small delay, and then I'll turn all of the LEDs off. Okay, add the quick delay from the variable tab here. Okay, now let's get started with the actual code for changing the LEDs. So we're going to need another loop now, so no, actually let's just do this a certain amount of times. Let's just say repeat 10 times. We're going to create another loop, so counting from J, which will be going from 4 all the way to 13 again. The first thing we're going to do is we're going to set the current LED off. The way we're going to do this is at the end of this loop we'll just increase the number of the current LED, but let's just watch this for now. So set the LED off on pin, which is on the pin which is created by getting the number of the current LED. So go to this variable and get current LED, do some quick math to it here. It may not make that much sense now for the first LED, but once we get through the process you'll understand why I'm doing this now. So again, we have the current LED, and out of that we decrease the number by 1. So we have the current LED, and then we decrease the number that's set by the direction. So on the variables, go here and select the direction. The direction basically changes between 1 and -1 depending on the direction in which the LED is headed. You'll see this as we're proceeding. So now we're going to set the LED on pin current LED. So just ignore the direction here. We're basically moving through the LED line and turning the previous one off and the current one on. At one point we're going to hit the end, so what happens then? We have to create a bit of a logic here. So if our current LED is 4 or 13, these are special cases. And basically we need to have an if and then an else if. Close this here. If our current LED is 13, which is where we're starting off in, we need to change the direction. So set the direction here to -1. Now it doesn't matter that this was initially the direction, we'd have to cover all the cases here. And then else if the current LED is 4, we have to do the opposite. We have to change the direction and set it to 1. That way, as the LEDs are progressing, if you start out at 4 and your direction is 1, it'll move over to LED 5, 6, 7, and so on until you get to 13. And then when you get to 13, it switches directions and it moves the direction variable to -1, and then you move back through the LEDs. Finally, we have to change the current LED by this variable that we have called direction, and that will either add or subtract 1 or -1. And then we add another quick delay just so that things don't happen all too sudden. Okay, so the last modification here was to change the current LED by direction. And let's see how this is running now. Initially we should get just a quick burst, and then the LEDs should start moving by themselves. There we go, it got to the end and now it's coming back round. And this will just proceed with a 400 millisecond pause in between the LEDs turning on and off. What I'm going to do is I'm going to connect this potentiometer here. It has 3 pins. The first one is the ground pin. The one in the middle is the 5 volts. And this one is the analog input, the third one, which is going straight into A4 for me. So remember A4, and now let's get back to the interface. In the interface, first we have to add a new signal, so go here under Signals and send this over immediately after the initialization of our 2 variables. I'm just going to call this signal 1, and its value will come from the pin access under analog read on pin 4. That's right, pin 4. Okay, then we need to change this, this delay that we have. So as our values change from 0 to 1023, I can't really go and add or subtract this value because it would mean the delay to be over 1 second. So I'm just going to divide that by half and basically go to Numbers and Math and do a quick calculation here. So we're going to have 700 minus the half of whatever it is that we're receiving from the analog read. So that would be analog read from pin 4 divided by 2. Okay, the next thing we're going to have to do is make sure that this signal is also being sent and updated as we're in the loop where we're actually changing the values. So copy this over to the end of the loop and also set the delay in the loop as well. And rather we do this right here after we change the status of the LEDs. And it's basically just a quick copy and paste, or duplicate and move in our case. One last thing we have to remember is to add our signal to the dashboard as well. So just click dashboard and then let's go here and add a speedometer. Make sure that the maximum value it can reach is 1023. Now this will update the colors a little bit, so make sure we go to the mid color at 400, sorry, the low value at 400 and the mid color at 800. And make sure that the signal name is signal. And now we can proceed. My board is connected, so let's just deploy the application. Initially, once again, my potentiometer is at 0. You can see the board is starting up right now. I'm going to slowly move up. As you can see, the signal is updating and the speed of the LED changing is increasing as well. I'm going to double that value to around 800, and you can already see it's speeding up considerably. And then the maximum value this one can reach is close to 1000 now. Clearly there is a significant increase in speed. I'm going to slow down now all the way to 0. And now my project is stopped because I've reached the end of my loops. If you remember, if we go here right to main visual, we only had it repeat 10 times. Okay, thank you so much for watching.